Okay, here's question 2. It says, a cone has a radius of 2 centimeters and a height of 8 centimeters. What is the volume of a similar cone that has a scale factor of 4? So in the notes, I copy and pasted the formula sheet that they used to give for Math 10 provincial exams, but it basically essentially has all the necessary equations for basic geometric shapes. So for a cone, if we're trying to find volume, you have to basically either look online or look at that formula sheet of volumes, and you'd find what is the volume of a cone. So volume of the cone is given as 1/3 pi r squared h. Oh, I forgot the r. Pi r squared. I said it. I just didn't write it. Let me just redo that. So it's pi r squared h. So hopefully some of you may recognize this is actually the equation for a cylinder. So if you have a cylinder, it's pi r squared because that's the area of a circle. And you multiply by the height, you get the volume of a cylinder. How it works for pyramids and cones, though, if we just divide that by 3, it gives us the volume of a cone. Okay, so for this one it says, let's find our volume right now. So we have 1/3 multiplied by pi. So look at our equation. It says a radius of 2 centimeters. So I'm going to put 2 centimeters right there. We're going to square it. That's what the equation tells us to do. And the height of 8 centimeters. So we're just going to take our calculator and plug this in. So we have pi multiplied by 2 squared multiplied by 8. And then we're going to divide that by 3. So we get 33.51 centimeters cubed. So that is the volume here. So there's different ways we can do this. We can solve for, just like in the previous question, we can solve for this volume and then multiply by this scale factor cubed, or we can find the dimensions of the scale model. So it says scale factor of 4. So if we multiply everything by a factor of 4, we're going to get 2 times 4 is 8, and 8 times 4 is 32. So we have our larger one, so I didn't have space to really draw bigger, but our larger scale model version of this cone is 832. So if we want, all we need to do here is we can go, let's replace, okay, our new radius is 8 centimeters, so we're going to 8 centimeters squared, and our new height is 32 centimeters. Now we can just plug this in, so we say, okay, pi multiplied by 8 squared multiplied by 32, divide that by 3, we get a volume of 2,145. I'll round it at the 1 digit. That is our volume of the cone. So technically we are done at this point. And the other way, the whole point of this whole topic though is trying to really understand k squared, and k cubed. So the other way I could solve for it, the volume of the bigger cone is going to equal to my volume of my smaller cone multiplied by the scale factor cubed, because again we're looking at volume. Volume is k cubed. So the key thing is length scale is k. Area scale is going to be k squared. Volume scale is k cubed. So if you know one, you know all the others. So I'm going to say, okay, k is 4. 4 to the power of 3, so 3.51 centimeters cubed multiplied by 4 to the power of 3 is going to be 64. So if I multiply 33.51 times 64, lo and behold, we get 2,145 centimeters cubed, which is the exact same value. Again, 2 ways to solve for these questions.